introduction part, we will take a look of one video that we have prepared. As you have seen on the video previously, there are two types of ball with different mass that being pushed. After being pushed, both balls show different speed. What we can conclude that from the video, the heavier the object, the slower it takes to reach its point. This video is actually related to Newton's second law. That is the experiment that we conduct for this assignment. What is actually Newton's second law? Newton's second law, also known as inertia, and it can be defined as the acceleration of an object is affected by the applied net force and its mass. The acceleration is directly proportional to the net force and inversely proportional to its mass. So the first one shows the relationship between acceleration and net force, and the second one shows the relationship between acceleration and mass. By combining these two relationships, we will be able to get the equation of force equal to ma, which is m equal to mass and a equal to acceleration. The objective for this assignment or this experiment is to analyze Newton's second law in one dimension. By analyzing Newton's second law, we will be able to determine the relationship between the acceleration and the net force, and we also able to determine the relationship between the acceleration and the object mass.
I will show the procedure of the project. In this project, we investigate the Newton's second law, also known as law of inertia. Firstly, you must open the simulation of forces in one dimension. For both experiment, friction will be turned off. In experiment 1, we want to see the relationship between the force and the acceleration. Pi cabinet is chosen because the mass of the object is 200 kg and the mass is kept constant. Next, the value of force is set to 100 Newton and start the simulation. The value of acceleration is recorded, and we can see the value of acceleration in the graph acceleration. The experiment is repeated with different force, which are 200 Newton, 300 Newton, 400 Newton and 500 Newton. For experiment 2, we want to see the relationship between mass and acceleration. In this experiment, the force is kept constant at 1000 Newton. The mass of the object depends on the object used. First of all, choose the object, for example textbook, and start the simulation. The acceleration is recorded and the experiment will be repeated by using different objects such as sleepy dog, crate, refrigerator and file cabinet. Result. The result for experiment 1. Using 100 Newton of force, the acceleration will be 0.5 meter per second square. Using 200 Newton of force, we'll get 1.0 meter per second square. Using 300 Newton of force, we'll get 1.5 meter per second square. Using 400 Newton of force, we'll get 2.0 meter per second square. And lastly, using 500 Newton of force, we'll get 2.5 meter per second square. In experiment 2, various objects was used to obtain the acceleration. First object used was textbook weighing 10 kg get an acceleration of 100 meter per second square. For sleepy dog weighing 25 kg get an acceleration of 40 meter per second square. For file cabinet weighing 200 kg get an acceleration of 5 meter per second square. For crate weighing 300 kg get an acceleration of 3.3 meter per second square. And last but not least, refrigerator weighing 400 kg get an acceleration of 2.5 meter per second square.
Finally, we are in discussion. It is the most interesting part of the project where we will discuss the result of the experiment, summary of our observation regarding law of inertia, importance of the experiment and the technical challenges we came across in performing this project. Let's not waste any time and get right into it. As you have seen in the procedure and result part of the video, the data obtained were recorded in two tables, which is the first table includes force and acceleration, and the second table includes mass and acceleration. From these two tables, we were able to obtain two graphs, which shows detailed representation of the result using Microsoft Excel. Microsoft Excel definitely comes handy in doing things like this. Once you get hold of it, life will be so much more easier. Let's look at the first graph, which is acceleration vs force graph, where the mass is kept constant. As you can see, this graph is a linear graph with the equation of A is equal to 0.005 F. This proves that the relationship between acceleration and force are linearly proportional, just as stated by the Newton's second law. In other words, the acceleration is increased whenever the force is increased, and the other way around. Alright, now we move on to the second graph, which is the acceleration vs mass graph, where force is kept constant. The shape of the graph itself shows that the relationship between variables is inversely proportional. The equation obtained from the graph is A is equal to 1003 over m. This shows that the relationship between acceleration and mass are inversely proportional to each other. In other words, the acceleration is increased whenever the mass is decreased, and the other way around. This relationship obtained is significant to satisfy the objective of this experiment and also to correlate to the Newton's second law, which we learned in this mechanic SFT3033 course, with the equation of F is equal to ma, with F is force, m is mass, and a is acceleration. Lastly, I would like to speak on behalf of my group members regarding technical challenges we came across during this project. Firstly, in constructing appropriate experiment that satisfy the simulation used, which require us to integrate detailed knowledge of ours. Secondly, we had to learn how to make a perfect graph for the experiment using Microsoft Excel. Lastly, one of my group members was not able to open the simulation, so we work on it and find other alternatives to accomplish this project.
Therefore, from this experiment, we have obtained the relationship between acceleration and force and also its relationship with mass. From experiment 1, acceleration is directly proportional to force, which can be presented by this equation. Then, from experiment 2, the acceleration is inversely proportional to the mass, which is represented by this equation. This is the list of our main references that we used to complete this experiment.